back to the class. Now you have 4 exponent x plus 9 exponent x equals 25, okay? Now by observation or by inspection, you can see the numbers in the equation are all perfect squares, okay? So we can write 4 as 2 exponent 2, okay? We can write 9 as 3 exponent 2, and then we can write 25 as 5 exponent 2. All right, so we're going to apply the power of a power rule of indices. So a exponent m times the exponent c is equivalent or equal to, okay, a exponent mc. So we're going to have 2 exponent 2x plus 3 exponent 2x equals 5 exponent 2x. All right, now the next thing we are going to do is to divide each term by 5 exponent 2x. So you're going to divide each of the numbers by 5 exponent 2x, okay? So we divide here by 5 exponent 2x, okay? Divide here by 5 exponent 2x, here by 5 exponent 2x. All right, now anything over itself is 1, okay? So this part will produce 1. So we're going to have, okay, 2 exponent 2x over 5 exponent 2x, okay, plus 3 exponent 2x over 5 exponent 2x equals, okay, 1. All right, so this is what we have. Now here we're going to apply the quotient to a power rule, or you can also say the power to a quotient rule. So it states that if you have a exponent b over c exponent b, this equals a over c exponent b. All right, so the equation becomes 2 over 5 exponent x plus 3 over 5 exponent 2 over 5 exponent 2x plus 3 over 5 exponent 2x equals, okay, what we have here, 1. Now, anything over itself is 1, okay? So in place of 1, we can write 5 over 5. All right, so this is what we have. So we're going to have 2 over 5 exponent 2x plus 3 over 5 exponent 2x equals, now 5 is the same as 2 plus 3. So we have 2 plus 3 over 5. All right. So our equation becomes 2 over 5 exponent 2x plus 3 over 5 exponent 2x equals. All right, so let's expand this part of our equation. So we can write this as 2 over 5 plus, okay, 2 over 5 plus 3 over 5. So you can see we have two separate fractions. Now here we are going to compare, okay? So by observation or by inspection, you can see that 2 over 5 exponent 2x is equal to 2 over 5 here, okay? And then you can also see 3 over 5 exponent 2x equals, okay, 3 over 5 here, okay? All right, equals 3 over 5. Now, any number there has a power of 1, okay? So you can say this fraction has a power of 1. This fraction also has a power of 1. All right, now let's apply the one-to-one property of exponential functions, okay? So it says that, okay, if a exponent b equals a exponent c, then you can say, then, okay, b is equal to c, okay? Now note, a is not 0, okay? So we don't have 0 exponent 0, okay? It doesn't work in this situation. Therefore, okay, we can use any of the equations we have here to find our value, for x. So you can call this equation 1 and call this equation 2. So you can use equation 1 to find x or use equation 2 to find x. Okay, so let's use equation 1. So from equation 1, we can say 2x equals 1. Okay, so you divide here by 2, here by 2. So x equals half. All right, now let's check if x satisfies the equation. Now we have 4 exponent x, okay? We have 4 exponent x plus 9 exponent x equals 25 exponent x, okay? Now, so you're going to have 4 exponent half plus, so you're doing substitution here, 9 exponent half equals 25 exponent half. All right, now half is the same as square root, so you can write 4 as the square root of 4, 9 as the square root of 9, okay, and then 25 here as the square root of 25. All right, so the square root of 4 is 2, the square root of 9 is 3, the square root of 25 is 5. So you have 5 equals 5. So you can see the equation is satisfied. So you can say, therefore, x equals half satisfies, okay, satisfies the equation. Okay. All right.